Hello everyone, in this video we will be solving problem 205 isomorphic string. The problem statement is given two strings s and t, we need to determine if they are isomorphic. Two strings are isomorphic if the characters in s can be replaced to get t. Let's look at the examples to understand this better. In example number 1, s is egg and t is add. If we start replacing the characters, so in this case e will be replaced by a, this G will be replaced by D, and because we have already identified G needs to be replaced by D, it will need to do the same in the last character. As the string S matches T after the replacement, we'll return true. In example number 2, if we do the same operation, F will be replaced by B, O will be replaced by A, but in the last character, O should be mapped to R to make the two strings equal, but because we have already identified the map for O, which is not equal to R, so we cannot make the two strings isomorphic, hence return false. I hope you were able to understand this problem statement. Let's switch to whiteboard and discuss how it can be solved, starting with a brute force or naive approach, and then we'll think about how we can improve it. In the brute force approach, we'll iterate through all of the characters in string S, compare it with the corresponding characters in string T. If they are equal, we'll do nothing else. We'll replace that character with the new character across the string. Let's do a couple of runs to understand how will this work. Starting with I pointing at 0, corresponding characters in S and T are P and T. As the two characters are not equal, we'll replace all instances of P with T. This will be the output after the first replacement. Now we'll increment our pointer. With I is equal to 1, corresponding characters will be A and I. As the two characters are not equal, we'll again do the replacement. So all A's will be replaced by I's. And we'll increment our pointer. So going for I is equals to 2, P and T. As we have already gone through P and exactly did the same operation of replacing it, we'll skip it and move on to I is equal to 3. Its E needs to be mapped to L. Let's do the replacement. This is the updated string. Now moving on to the last character. For R and E, as they are not equal, we'll do the replacement. The output should look something like this. After the iteration is done, we'll compare this against the T string, and if they are equal, we'll return true. I'm sure you must have noticed, as we were using this approach to solve the problem, we were doing multiple operations in replacing the characters across the string. We started with replacing P's, then we started with A, E, and then R. So our time complexity and space complexity is going to be huge and grow exponentially as the size of S and T increases. So this is not going to be a scalable approach. Let's think about how we can improve this to make sure our time and space complexity is not very high. Another way to solve this problem is by using Hashmap, where we'll save the maps that we have identified to make sure the strings are isomorphic. Let me do a couple of runs to explain how will this work. Starting with I is equal to 0, does the key or the value exist in the hash map? It does not, so we'll go ahead and add it. Continuing further with I is equal to 1, we are looking at A and I. Let's check if the two exist in the hash map. It does not exist, so we'll go ahead and add them. With I is equal to 2, we are looking at P and T. As P already exists in the hash map, we'll compare its corresponding value with the character in T, which should be equal. If they are not, we should stop the iteration and return false. But because in this case the two characters are equal, we'll continue forward. Similar to the last runs, we'll add the remaining maps to the hash map. Once we are done with the iteration and there are no such errors that we encountered, we'll return true. There is one more edge case that we need to think about when building this solution. Let's take an example where S is ABCD and T is AARP. So with these inputs and the logic that we just discussed, the hash map would look something like this and it will return true. But this is not correct. If we reverse the strings and apply the same logic, the output will be false. Because we have two characters A in string T, but both of them are mapped to a different character in string S. So when we were doing the comparison to make sure the key exists in the hash map, we also need to make sure that the value also is the same. So if we were to do that same check, we'll first compare if A exists in the map, yes, then compare its corresponding value that we need to replace if they two are matching. If the two match, great, we'll continue the iteration, or else we'll stop the iteration and return false. In this solution, our time complexity is O of n, where n is the length of the string, and the space complexity is also O of n, as we are maintaining the hash map with all of the characters that needs to be replaced to make the string isomorphic. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by checking if the length of S and T are not equal. If they are not, then I'm returning false. And then creating this dictionary or hash map of type, character and character. In the for loop, I'm creating these two local variables, original and replacement. Original is pointing to the character in S, while replacement is the character in T. I'm then checking if the original character exists in the map. If it does not exist, then I'm checking if the replacement exists as a value. If both of them return false, it means we have encountered this pair for the first time, so I'm adding it to the map. If the replacement exists as a value but it is against a different character or a different key, it will go inside this else condition and return false. If the original character exists in the map, we'll go inside the else condition and compare the value. If the values match, we'll continue the iteration or else return false. This code, when submitted on LeetCode, beats nearly 79% of the submissions in terms of runtime complexity and 72% in terms of memory consumption. Thank you for watching this video. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.